Welcome to our latest research farm. This is a 54 by 500 foot house that's using tube radiants to provide supplemental heat during brooding. What makes this house unique is we're using low intensity radiant tubes as opposed to the standard high intensity radiant tubes. What's the difference? The other houses on this farm, there are 8 20-foot tubes that run the length of the center of the house, each having 80,000 BTUs. This house has 8 80,000 BTU heaters, but instead of being 20 feet long, they're 40 feet long. So we have twice the tube length, which does a much better job of distributing that heat over twice the area. The challenge when we have a single row of tube heaters in a house like this is the middle will be really hot and the sidewalls can be sort of cool at times because we're producing a lot of radiant heat in the middle and not much on the sidewalls. It's not that different from having a row of really bright lights down the middle of the house. The middle of the house would be very bright and the sidewalls would be dim. So envision this house. We have the 2 rows, 4 tubes on this side of the house, 4 tubes on that side of the house. Each tube is 40 feet long, running the 250-foot brooding area. So we have tubes running right along the feeders down here with a maximum gap between the heaters of around 20 feet. So we have a continuous amount of radiant heat running right down the outside feed lines. You say, well, it's going to overheat the feed. I'm going to get my chicks too hot. No, because these are low intensity brooders. They're taking that same 80,000 BTUs of heat and distributing over twice the area. So what we're going to get is much more uniform floor temperatures. You say, well, one of the end of the tube will be hot, the other one will be cool. No, these are very special heaters. Our research with them last winter, some preliminary research, we found that there's only a 10-degree temperature difference between one end of the tube and the other. The other interesting thing we saw is that it's much cooler above the tubes. Instead of having that 80,000 BTUs concentrated in a 20-foot area, we're taking the 80,000 BTUs and distributing over a much larger area, which means our ceiling temperatures only get up to maybe 110, 115 degrees, as opposed to the 115, 60 that we see sometimes. So what we're going to do, we have our heaters here. Our sensors are going to be very close to the heater, which is not very normal. But because we have such good coverage area, what we're trying to do is get a certain amount of floor temperature right here around the feeder right there. It won't be cold in the middle, and it really won't be cool in the sidewall because this radiant tube is throwing the heat over towards the sidewall. So what we're looking at here is really a different way of looking at radiant heating. Not just saying, well, we have 50 BTUs per square foot. We're also looking at coverage area. And what we have seen with this next generation of heaters is that we take the same heat and distribute it over twice the area. So twice the birds get the potential benefit. There's still a lot of questions to answer about, is there fuel savings? What will it do for litter moisture? Where exactly we should put the sensor? That's what we'll be learning this winter. We'll keep you informed of our findings as we go along, but hopefully this could be something that could really save some growers some money and be able to produce birds with drier floors and lower ammonia levels. Thank you.